All right, I think we're going to go ahead and get started. Hello and welcome. My name is Dan Miller. I work for Unity Technologies as an XR Evangelist, which means I focus on augmented and virtual reality, build a lot of sample apps, and really just help the community. This talk is titled Get Off to a Great Start with Handheld AR, and we have a lot of exciting AR/VR talks today, specifically on this XR track. I'm really honored to be able to kick that off. So as an overview, what I want to do is start by just kind of defining what I'm talking about with handheld AR, giving a little bit of insight into how it works and some of the basic features. Then we're going to go and show just a couple demos that I've worked on and built, as well, and kind of explain how they work and how you guys can build things that are similar. After that, I'm going to take a little bit of a deeper dive into ARCore and then ARKit, talk briefly about some tips, and then look at AR Foundation, which is our solution for abstracted APIs on top of ARCore and ARKit. And so when I'm talking about handheld AR, I'm specifically talking about augmented reality that works on your handheld or mobile devices. So these are cell phones or iPads. And the way they work is something called Visual-Inertial odometry, which is basically the correlation between the camera's vision and how the computer is processing that, as well as the IMU sensors like the accelerometer and gyroscope. And as these devices move around the environment, they're able to pick up on things like feature points to really establish themselves in the world and be able to track both their position and rotation. And some of the core features that are included are things like horizontal and vertical plane finding, positional tracking, like I mentioned before. As you kind of establish yourself and as you found a ground plane, then you can really move throughout, query the position of your camera, and use that for interactive applications. And last but not least is light estimation. And what this is a way to take the ambient value of your current lighting and use that to either shade or brighten your models. And it's really just a step in towards understanding more about the environment and then using that to kind of place your models in the environment. All right, so let's go ahead and walk through some demos. So this is my personal device, so hopefully I don't get any weird text messages or things like that. But I have laid my hoodie here just to use it as a way to find feature points. This stage, as well as this kind of backdrop here, is fairly, let's say, featureless. There's not a lot going on. And you can see that the technology here has actually detected my hoodie, and that's why I put it here, because it just adds kind of visual noise to this stage and can be used to more easily kind of place things. So what I'm doing here is I've found a kind of plane relative to my hoodie there, and every time I tap, I place a little Unity cube. I can also kind of look back at these chairs here and potentially find a plane there and start placing little Unity cubes there as well. And so this is a fairly simple application. It just finds planes. Every time you tap it, it places an object there. But you can see that they're fairly well kind of locked there. And as I move around more, it builds up more of these planes, and you can start placing the things there. So this is kind of the core or very basic application of both ARKit and ARCore, where you're simply finding planes, tapping, and placing objects on them. So the next one I want to show is a little bit more advanced. You guys can see a lot of my icons there. But what we can do here is, I'm going to go back here, and I've also placed my little journal here, to try to establish a ground plane. So we can see just scanning around here a little bit, right there. And what's happening is that now that I've established myself in the world, I can hit this start button, and I can start walking through it, moving around a little bit. And then when I turn around, you can see that I've actually laid little breadcrumbs behind me in the exact motion path at which I walked. And that, again, is using this core technology to just track where I'm going. Inside of Unity, this is just the main camera. And as I move throughout the space, and every time I get, let's say, a meter or 0.75 meters away from where I was, I drop this little item behind me. And you can imagine maybe I was, wandering through the woods or something like that. I got lost, but I happened to be running this application the whole time. And I can kind of trace my steps back, find my way back to where I was. So this application here, it's not super advanced, but what it does is it spawns a MRI scan here, and using the camera, again, as a positionally tracked object, you can kind of go in and penetrate through this MRI, and as you get closer, it fades out the different layers. And it's actually really cool when you do it from the top, and you can see me kind of going through, checking out the different pictures of this MRI as I move my device closer to the object itself. All right, and this other one that I want to show, what this does is this actually, you can see I have a little figure here, and once it's detected, it actually spawns objects relative to that figure. So this is Unity Chan, and this is Halloween Unity Chan, and she has a little message for you guys. Hello, Unite LA. So what's happening here is that I've actually scanned this model and built it into my application. This is a feature that's unique to ARKit 2.0, and I'll be talking about this a little bit later on in the presentation. You can see the nice thing here is that once it's kind of been established, I actually don't need to look at it anymore. I can still visualize this kind of off to the side, and the core technology is able to keep that stable and on top of my laptop there. And last but not least, this is one of my favorite applications that I've worked on recently. And what it does is it combines a lot of nice things with some really clean kind of implementation of things like the UI, the plane visualization, as well as just spawning some objects here. So what I'm doing now is you can see before that I was kind of informing my users to move the device around a little bit more. And now I'm telling them to just tap to place. And what we're doing here is we're using a focus circle to just kind of instantiate there at the center of the screen. So we can see if we can find some planes back here and place one on top of my backpack, as well as on the sides here. So again, it's really subtle, but we are kind of visualizing the plane there and then fading it out to not add visual noise to the experience. And then there's some really kind of small little juice there that I'm adding every time I spawn a ball. It kind of jiggles a little bit and things like that. One thing to note here that I personally am really kind of excited about and am going to kind of continue to build applications on is that instead of using texture rendering here, I'm actually just using vertex colors. So there's some nice kind of gradients painted into the vertices or in the vertex information of these objects, and then I'm using a really simple shader to render that. And so if I get close to the object, you don't actually see any kind of pixelization because it's not using a texture, it's just using vertex colors there. All right, so those were some demos that kind of showcase what the technology can do, as well as how you can take advantage of it to build some applications. And now I want to start talking specifically about ARCore. What are some of the unique features? How can you start building on it? And really what's available to you as a Unity developer. So to start, the ARCore application, or the SDK, is managed by Google. You can find it available on their GitHub that I've listed there. And it basically covers all of the features and is up to date with ARCore 1.5. There's a couple of sample scenes that are included that allow you to just get started right away. To me, the Hello AR scene, which is a very simple example of, again, horizontal and vertical plane finding and placing a little Andy the Android model. It's perfect for just starting with duplicating that scene and swapping out that Andy model so you can start visualizing really any 3D model in AR right away. They also have additional scenes for things like augmented images, which I'll talk about in a moment, cloud anchors, as well as computer vision, where you can actually take the image from the camera feed and run your own CV algorithms against those. And some of the unique features to ARCore is something that we call oriented feature points, that while I find information about the world, the feature points actually have a directional vector associated with them. You can see here I'm placing a little Andy the Android on my laptop that is at a slight slant there in the world, and they're still able to go relative to that exact position. And again, it's using these feature points, I'm doing the hit testing based on them, and using that oriented value, which is just a directional vector, to place and rotate my objects here. Some other unique things are cloud anchors, which I'll talk about a little bit more here, but it allows you to find a space in the world, place an anchor, sync that up to Google Cloud, and then relocalize or refine that same anchor with a different device or at a later time. And last but not least, they have an instant preview version that allows you to push an APK to your device and really iterate a lot quicker as a kind of remoting feature from an Android device to the Unity editor. All right, so augmented images. The cool thing about the way Google has implemented these is that you can actually multi-select just images in your project. They've integrated it into the Create menu, so if you multi-select a bunch of different images, right-click, go through Create, you can create what they call an augmented image database directly in Unity. After you've created that database, they actually run the computer vision algorithms on those in the specific editor and score those for you right away. So you can see here that with these selected images, we have pretty high quality values. And you can use that as kind of a reference to understand how quickly and how well they'll be recognized in your environment. They do recommend an 85 or above, and you can see these images are fairly unique. Now, something that was added recently is the ability to actually do this at runtime. So as you're scanning and understanding your environment, you can take pictures, upload them in, process them through this process, and then use those as anchors in your experience. And here's just a small example of what's possible. For me personally, what I really like about this example is that it recognizes the image, and then instead of just turning something on or flipping it over, it actually just fades out a little bit and then presents this nice 3D world with this kind of indent into the wall itself. And now I want to talk a little bit about cloud anchors. So as mentioned before, what you can do is you can scan around an environment, place an anchor in the world, and then use that to relocalize, create multi-user experiences, and really just kind of sync anchors across devices or across sessions. It's obviously all powered through the Google Cloud Platform, and it's really easy to take advantage of, start building on top of, and then just sending kind of normal messages or networks between two devices. All right, so that was a little bit about ARKit, and now I want to kind of go into some of the features of AR. Sorry, that was a little bit about ARCore, and now I want to go into some features of ARKit. All right, so unlike the ARCore integration, the Unity SDK integration for ARKit is actually maintained by us. What that means is that there's a lot of sample content that you can start building on top of for a lot of the unique features of ARKit. You can easily kind of duplicate these scenes and really get started. And there's even some things for kind of UX or understanding how to scan around and do some cool things like shadows and occlusion using the found planes. All of the 2.0 features, which are the newest iteration, are out on the master branch. And when those were first announced, they were actually pushed up the day of. So if you want to start taking advantage of these unique features as the SDKs and platforms start to advance, you can do that really easily. So some of the unique features here are world maps. What this is this is a way to scan around the environment and use what you found with the feature points and the planes to actually relocalize applications. This little example here is myself and Jimmy, who does a lot of the heavy lifting on the ARKit plugin. And what we've done is we've both scanned the same environment, synced that world map to the server, and then sent that down to the other devices. And once they've established themselves, they can then relocalize in the same space for this multi-user experience. What's happening here is that Jimmy is walking around tapping his screen and placing the dark purple balls. And I'm tapping around and placing mine, placing a lighter purple balls. And you might be wondering, how was this even recorded? And we actually connected a third user to this experience to record from an iPad so that we could get some cool visualizations here. And again, this is taking advantage of world maps. ARKit also has environmental probes, which allow you to understand the environment and then plug that into a reflection probe. I'll be talking about a little bit of that in a second. Last but not least, we have the trackable images, which is similar to what ARCore can do, but instead of just recognizing images, you can actually track them as they move around as well. There's also object scanning and recognition, which I showed a little bit earlier in my demos, as well as facial tracking, which is unique to the iPhone X series of devices. So for environmental probes, this is actually something that I was super excited about and I really like building applications for. And while I might be kind of pushing it to the extreme, it is just a really cool kind of piece of technology and feature that allows you to put objects more kind of integrated in understanding of the world. So what it does here is as you scan around, it actually builds a cube map up of your environment. So when it finds certain planes and feature points, it's starting to kind of fill in this cube map. And then what we're doing on the Unity side is we're taking that cube map and applying it to a reflection probe. So you can see in the two examples here, that object there is kind of reflecting the bench as well as the floor in the office over here. And the way this feature is more intended to be used is actually just as a subtle type of reflection to just really understand the lighting model as well as the texture detail in your environment so that as you augment objects into it, they just fit a little bit better. Now what I'm doing here is just taking a material, adjusting its shininess and reflection and just kind of putting it to the max to more showcase what is possible. And one thing I want to keep in mind or kind of tell you guys about this is that it does use these planes and feature points that are found. So when I was doing some of these examples, I was kind of scanning up in the air, and because there's no feature points, there's really nothing to lock onto, it's not going to really capture any data from that. All right, so now I want to talk about object recognition. So this is something that was released with ARKit 2.0, and it's pretty cool to be able to really capture a 3D model and then build it in its recognition into your application. So how does this work? The first thing that it does is you either need to run the Apple application that's on their SDK, and that's what you can see over there closest to the text. And what that allows you to do is really just scan the object itself. On the other side here, we have the application that's inside the Unity ARKit plugin. So you can just build this out to your device as well. And really what you need to do is you need to set a bounding box around your object. After you've established a bounding box, you need to start scanning and understanding feature points from kind of different sides of it so that the algorithms and the object can be a little bit more easily recognized. You can see there that on the left there with the Apple plugin, I'm actually trying to kind of create the scan of the object floating in the air. And that's something that I realized as I was iterating on and building these demos, is that depending on how you scan, where your object is positioned might be picked up in the scan. It does use color and lighting data in the scan itself. So if you scan something in a super bright environment and then try to replicate it in a darker one, it might not work. So that's something to keep in mind. And through this whole scanning process, what you actually get back is a file type called AR object. In the Apple application there that you can build out to your device, you can actually airdrop this to yourself. So what I did is scan the little Unity Chan figure, airdropped it to my Mac here, and then built that as a recognized object within my experience. And so once we do that, then we get something like this. And what happens in the kind of scanning process is that you also establish an anchor for your object. And so once this scan has been recognized by the ARKit plugin, I then can just spawn really anything relative to this anchor. So what I'm doing is I just have a little clip here with some pumpkins and Halloween Unity Chan, because it's close to Halloween. And I'm just setting that relative to that anchor of the object that I've scanned and recognized, and then just playing a timeline. And now I just want to talk a little bit about face tracking with the iPhone X, as well as the new variants that were released recently. So the core features here are a face anchor, which allows, again, a transform or a position relative to the user's face. Facial mesh geometry, which can be generated at runtime and used for things like occlusion. And facial blend shapes, which allow you to drive either 3D models or just interactions based on what you're doing relative to your face. So some examples of these. So at the top, we have the face anchor, and this is Jimmy as well. And one thing to keep in mind here is that it's not on the tip of his face. It's actually kind of in his head a little bit. So if you're putting things like a mustache or glasses, kind of keep that in mind. On the bottom there, we actually have the facial mesh geometry being generated at runtime and the output of the blend shape values as he's kind of moving his mouth. And over here, that's me. And what I'm doing here is I'm actually using a combination of all of these features. And it's a little bit subtle, but what I'm doing here is I'm parenting a particle effect to my head using the face anchor. I'm using the facial mesh geometry as an occlusion mask. So if you look at the particles coming out of my mouth, you'll notice that they're right there actually relative to my lips. And the last thing I'm doing is I'm using the blend shape values to spawn or activate the particles. So when I open my mouth and when the blend shapes have crossed a certain threshold, I just turn the particles on and they're all kind of relative to my face there. All right, so now I just want to talk a little bit about a couple tips in order for you guys to kind of get started and understand some of the stuff that I've been working on. So the first one is to just use feature points. Depending on your application, you might not need to find and establish an entire ground plane. If you're doing something like measuring, it's much easier to actually use feature points and raycast against those instead of trying to establish an entire plane. So if I wanted to measure the height of this podium, I don't necessarily want my user or really want to kind of scan and understand a plane at this top spot, scan and understand a plane at the bottom. So you can just raycast into the world using feature points, establish an anchor there, and then start kind of moving down there to establish another anchor and kind of measure the distance there. The next thing is just understand your tracking state. AR technology, and especially on the mobile end, is a lot newer, and the users might not fully understand what they're doing. Things like ARCite have ways that when tracking is not good, there's actually reasons you can expose to your user. Whether it's things like excessive motion or low lighting conditions, think about informing your user about this so that they can have that better experience. And last but not least, check performance. I've done a lot of kind of sample development to try to put a lot of things into AR, and there's been some times where I've just built an application and then be like, man, the tracking's just not working. You know, things are kind of drifting off or nothing really feels locked in the environment. And the reality is that the performance was bad on that application. I was either trying to push the limits of what's possible on mobile, and while the camera feed might look fine, the tracking is going to be greatly worsened by bad performance. So just make sure to keep in mind that you're still building for mobile devices. And ARCore specifically runs at 30 frames a second, and ARKit can do 60. So I just want to show this small video here. And what this is this is a way to actually kind of visualize and think about size within your applications. So the first thing I want to talk about is just kind of guiding your user and understanding what they need to do. A lot of these applications, you need to establish a ground plane. And so thinking about UI or ways to get your user moving is a good way to start to build your experiences. And the next thing, and what this video is really showing off here, is using real-world size. Within Unity, similar to VR, when you author this content, you need to think about how big or small it is. So that's the basic Unity cube there, so it's just 1 meter. But in my development, I've built a lot of applications, I spawn the object, and I just don't see anything. You know, what's not working? And half the time it's that the model was really, really big, and I kind of spawned it inside myself. So if I walk like, 10 meters away, I can look back and actually see it. So just keep that in mind when you're authoring this content. And the next thing is just think about kind of object interaction. Most of the time when you spawn this content in the world, you really want to adjust it or move it in the X and Z vector, rather than moving it kind of up and down in the Y. And the way that the rendering actually works is that it renders the camera feed and then the digital objects. So if you put it kind of down into the environment more, it'll just be a little bit confusing to your user, but it's still going to kind of render. It's not going to be occluded by the ground unless you're doing some additional things there. So you might have noticed in this video that everything actually has accurately shaped shadows. And for me, especially with Handheld AR, I try to add a lot of shadows to my applications. And that's because in the real world, almost everything produces shadows, unless you're in some sort of like photography studio or something like that. And what I'm doing specifically here is I'm actually using a shader from the ARKit plugin. And what it allows it to do is cast shadows on transparent geometry, which is usually not a kind of built-in feature. And so with that, every plane I find is allowed to accept shadows, and I'm just using a real-time directional light there. And this, again, just kind of helps ground a lot of objects, and I was using that in my object recognition demo earlier as well. Now, you don't always have to use full accurately shaped shadows, and more often than not, just simple blob shadows will actually suffice. So in my little balls demo that I showed earlier with the vertex coloring, I have small little subtle spheres or circles that are used as the kind of shadows and as the bottom of those objects. And it really just helps ground things a little bit more. And again, this is kind of mobile applications. And this is used pretty heavily in mobile gaming. So I talked a little bit about your device being tracked when I showed the little breadcrumb example as I moved around on stage. But I think this, to me, is what's really exciting about this technology. And you should really try to get your users moving. Whether it's kind of getting up close to an object and triggering a different interaction, like you can see here in the wink, or just kind of moving throughout the experience. It really enhances the user's experience and adds a lot more immersion to your applications. And the way, again, it works in Unity is once you've established the tracking within your session, you can just query the position of the main camera for the relativeness to your object or as you just kind of move around the environment. All right, so I've talked a little bit about both ARCore and ARKit, described some of the unique features to both and how you can start building some of the applications and taking advantage of those. And now what I want to talk about is AR Foundation. And AR Foundation is the combination of ARCore plus ARKit exposed to you through an abstracted API built into Unity. So what does this allow you to do? Well, it allows you to build applications with the same code base for both Android and iOS devices. Here we have that simple app that I was showing earlier where I'm spawning little kind of stands with the Unity cube on it. And on the left here, I'm using an iPhone 10. And on the right, I'm using a Samsung S8. What AR Foundation does is it covers these kind of core features that are shared between both of the platforms. And why is it important, or why do you as a developer want to take advantage of it? Well, some of the key kind of wins here is that it's delivered via the package manager. And if you've used any of the package manager before in the kind of the 2018 version of the editor, what it allows you to do is instead of pulling in a bunch of code and assets into your project, it allows you to just reference them. So within packages, you're able to get the SDKs and the implementation of ARKit and ARCore without bloating up your project. So it creates a really clean implementation that you can start taking advantage of these APIs. The other thing is that it's super easy to extend. That balls application that I was showing earlier is actually built on top of AR Foundation, and that's where I'm moving a lot of my development because it just covers these core functionality, and then it doesn't matter what device you're working on. And last but not least, it's just kind of, again, that single project that you can deploy to both platforms. So as mentioned, it's available via the package manager. You can download it right away, or download it today. It's been released in 2018.1. And it's just covering the core functionality for now, but it is getting up to date with ARKit 2.0 and ARCore 1.5 features. And that's something that our AR team is working really actively on. There's actually another talk today that goes a little bit into the future of AR Foundation and how we're bringing more features to it. And there's been some work recently on things like support for the lightweight render pipeline. So if you're building applications that take advantage of things like the shader graph and want to put that in augmented reality, the AR Foundation plugin supports that for both ARKit and ARCore. Now, because it was kind of targeted initially at these cross-platform APIs, you can see some of the core functionality that's listed there on the slide. So it allows for horizontal and vertical plane detection, light estimation, hit testing, as well as things like scale. But again, it's not going to cover all of these unique features yet. So I showed that object detection a little bit earlier, and that is, again, a unique feature to ARKit and is not quite exposed in AR Foundation today. It is stuff that we're working on because we really want this to be those cross-platform APIs that you start building all of your applications on top of. And if you want to get started, there's also a sample project that you can download for ARKit that basically just has the manifest file set up and shows you how you can start finding a plane, taking advantage of some APIs, and then spawn objects on them. One of the things besides lightweight support that was added recently is the ability to render planes with a nice feathering. So as the kind of edges of the planes are detected, it then fades out to a transparent surface, which just applies a lot cleaner visuals to your projects. All right, and that's pretty much it for my talk. So if you guys have any questions or anything like that, I think we have a little bit of time for that. But thanks a lot for coming. Is there any questions? I think we have some mics set up there.
Yeah, I got one. Performance-wise, if we're using all of the features all in one project, let's say we're trying to use multiple AR anchors and we're using plane detection, all that stuff all in one scene, is it still performant if you have a lot going on? And yeah.
Yeah, I mean, you know, the reality is that a lot of these features kind of rely on each other, especially that core technology with the plane finding and feature point detection. So yeah, it's kind of built to be performant utilizing those. The one thing to keep in mind is if you're trying to, you know, put too many polygons or too many textures or too many objects, that's where you start seeing some hits.
How far backwards compatible are we with older phones and things?
Yeah, so both ARKit and ARCore kind of have a supported devices. So on the ARKit side, it's anything running iOS 11 and above. And on the ARCore, it's kind of a per device spec that they've put. The thing is, in order to get this technology to work, they need to calibrate the IMU sensors in the manufacturing process. And they've been working with things, certain partners like Samsung. Obviously, all of their Pixel phones work with it. But those are both specs kind of listed on the website for each platform.
Cool, thanks. So one more. Does Foundation support vertical planes?
Yep. Foundation supports vertical planes, and there has actually been a lot of questions about this. And people are like, man, I didn't know it supports vertical planes. I have only seen horizontal. And the reality is that both of the technologies support that, but more often than not, walls don't have a lot going on. It needs feature points. That's why I put my hoodie down here. That's why I put my journal over there, is that it needs interesting things in order to detect a wall. And while that wall back there is pretty unique and probably would work well, more often than not, you're looking at like a plain white wall. And so you're not going to detect that. But yeah, that is available in AR Foundation.
Perfect, thanks.
Yep.
The ARKit real object scanning, does that also include tools to sort of clean up the object and texture?
It doesn't. So the way it works is it's a proprietary format on OS X, and it's .AR object. And what you do is once you scan it, it does in part of Apple's implementation of the object scanning, it does allow you to set an anchor point. So once you've scanned an object, you can actually determine where the anchor is, and you can think of that as kind of the transform within Unity. But there's really no way, as far as I know, to kind of go in and do anything with that object, except use it for the object detection within your app.
Oh, so the example you showed wasn't like, you weren't animating a scan of that same model. You would grab a different model and spawn it in on that anchor?
I mean, that model is just this one up here. Yeah, what was the question there?
Well, so the animated example.
Yes. That is just another asset that was available to download for free. Yeah, good question. And the other thing to keep in mind is that this scanning functionality is actually available at runtime. So you could create an app that scanned an object or scanned something, and then build that or use that as a recognized anchor within your app. So if I wanted to kind of scan this in the current lighting conditions and then use that to anchor content to, you could do that at runtime. Yep.
If I wanted to use a feature that was like unique to ARCore, like the cloud anchor or something like that, would that still compile to iOS going through AR Foundation?
So AR Foundation right now does not support unique features. That's something that's being built up in what we call subsystems. So being able to, again, take advantage of those unique features. And the big thing with AR Foundation is that you're not looking for platforms. You're not saying, is this Android, is this iOS? You're just looking for features. And right now, Cloud Anchors is not supported through AR Foundation. The way Cloud Anchors works is that you can actually compile it for iOS and Android, and it can do some agnostic stuff, but that's specifically on the ARCore side.
Cool, thanks.
Yep.
Hey, I actually also had a question about the cloud anchors. So my company's use cases are typically like trade show environments where internet might be a little spotty. So is it kind of, in order to use that suit, is it always requires a steady internet connection? Or so anything short of that would require like a homebrew solution or something like that? Okay.
Yeah, so cloud anchors do need to kind of ping the cloud services and relocalize based on that. On the opposite side, with the world map APIs or examples that I showed, the world map is actually kind of a local object there. So they don't send anything like that up to the cloud, and you can just share that between devices or between applications without syncing it with an external network.
Awesome, thanks.
Yep.
Referring to the world map feature on ARKit, can those be used to like add data to the environment over time, or add tracking data over time? Like you restore one, and then you visit the same environment on another day, and then add more feature points to it and continue to build?
Yeah, I mean, it really depends on how you build your application. The general feature there is that you can scan a kind of larger object. So we saw the object recognition. I'm using a fairly small model. With world maps, you kind of just scan around and understand the environment at a larger scale. The way it works is that once you've established that world map, you can then kind of send it off. And as you go and move around more, then it goes back to kind of building it back up and building a bigger world map. Whether you're adding content to that and storing it or caching it on something like a server is really kind of up to you. So the potential there to continually return to the same space, recognize it, and add objects or data is definitely possible.
Like adding feature and tracking points as well, does it do that?
I guess, what do you mean by feature tracking points?
I guess so that every time you return to a spot, you would have a better understanding of that environment.
Yeah, I mean, potentially you could modify that world map, or you could kind of build it up more and more. The one thing to keep in mind is that I've had some problems where I scanned my couch, and then I put a bunch of pillows there, or put a blanket, and it didn't quite recognize it. But yeah, the idea there is that it establishes that scan, and it's able to relocalize and really put any content relative to that.
Okay, thank you.
Yep.
Hi. Do you have a favorite AR app or AR game worth checking out?
I don't personally. I did play a little bit of Pokemon Go, and the things they've done recently with the ARKit and ARCore integration are pretty exciting. If you guys haven't checked those out, they actually do establish a ground plane put some little kind of grass objects on that, and then once the Pokemon spawns, it's really grounded in your environment, and then they're doing some simple distance checks that if you run up to the Pokemon, it actually runs away. So they're doing some kind of cool stuff with the ARKit and ARCore implementation. They obviously launched without that, just using the camera feed. But yeah.
So I just wondered, is there like a limit on the space that these applications can remember where things are? So say you had a room about this big, say it might be a showroom, for example, with lots of different interesting points. Without using markers to kind of refresh where it is, can it consistently remember?
Yeah, so I mean, there's kind of two parts to that question. One, you know, that little breadcrumb app that I joked about walking through the forest? I have actually walked what I would consider like fairly long distances with it, and it just kind of maintains and works just fine. You know, it's establishing and building up a plane. For trying to scan and remember something like a room of this size, you might start to hit some limits. The one thing to keep in mind is, you know, the scanning process and the recognition is kind of based on hardware. So for that object scanning of just the little Unity Chan model, it actually recommends using the latest hardware. You're going to get better and more featured scans and create larger scans on something like the new variants of iPhone 10. What I would do to recognize a room like this, instead of trying to establish or scan the entire environment, I would instead have a starting position. So I would say something like, you know what, I'm going to scan this entire doorway, all these doors, all this exit sign. Once I've relocalized to that, then I just know the distance, because it's kind of a known distance from every other object in the world. And then as you move throughout the environment, it can establish that tracking, and it can keep things kind of locked in their place. Does that answer your question?
Yeah. Essentially, the idea is that we've got a showroom, and we were thinking about having a digital avatar be the person that takes you around.
Mm-hmm.
So obviously, then that sort of solution where you have that starting point and distances would work, I think.
Yeah, and you know, there's a lot of people kind of asking about, you know, how do you navigate indoors, or how do you do things like that? And you know, something that people think about initially is GPS. But the reality is that consumer-grade GPS, it doesn't know if I'm here, it doesn't know if I'm over here, it barely even knows if I'm across the street. And with AR, you know, it's a lot of these kind of localized, smaller scale applications where you're looking at more of this meter scale and not GPS. So you need to kind of establish yourself, set a grounding point before you can start kind of moving through the environment or relocalize things. I think we have time for one more question.
Okay. Do you know if any of these technologies return pinch to zoom that you might do, you know, on the phone to the code to be able to respond to that?
Is the question just how do you do pinch to zoom for AR, or?
Well, yeah, you know, A, does that function, but B, does any of these technologies return that so I can know within my code that they have pinch to zoom, kind of like your blinking interaction. I want to know if somebody has zoomed into something and then react to that.
Yeah. So it's still just a normal mobile device, so you can query both touch positions and then kind of check the distance or check how it's being adjusted over time. And a couple of the AR apps that I've done, after you spawn something in the world, you actually pinch to zoom to scale it up, or vice versa, kind of pinch to scale it down. So yeah, it's just normal mobile. You can just query the touch positions and gather that, or there's some other APIs and tools built on top of that. Yep. All right, thanks a lot, guys. If you have any more questions, I'll kind of be outside and hanging around the show floor today.